In this tutorial, we are going to learn how to write the motor initialize my block. Uh, so over here, my robot is already connected. You can see it's streaming data. So when I move my robot, you can see the numbers changing. Over here is my camera showing the robot and the wheels. So we are going to first find out which is our right and left motor, because we need to insert that in our movement motor blocks. So in here, first we have to set our movement motors to us, the ones that they are. We have 6 ports over here. So let's pull up our camera and see what we have so far. So when we move the left hand side motor, we can see the A port flickering, and then when we move the right hand side motor, you can see the E port moving. The numbers are moving. And this is particularly important to keep in mind. Like, so here's the color sensor, and you can see that B shows red over here. And then when I move my finger over here under this color sensor, you can see the F shows a red. So again, B and F. And this is A and E. Changing these motors will show you that this is D and this is C. Okay, so it's important to know a map of where our motors and sensors are. So you will see that I have prepared a map over here. This is kind of important when you're starting to program for line followers and for movement. So for this tutorial, we need to know that A and E are our movement motors. Now the right and left is also very important. So let's go back to Spike Prime and set it to A and E. But so it's also possible that yours are switched around, and make sure that you change it out. If it's E and A, your program is going to run in reverse, because the program kind of knows that this is your left and right. So make sure that you have them in the right order. This is important. The next thing we want to know is how big are the wheels. So what is one motor rotation equal to? Now to know this, let's go back to our camera, and you will see that we have these wheels, which are like the bigger wheels. So there are 2 types of Spike Prime wheels. One is the small wheel here. So one is the small 5.6 wheel, and one is the 8.8 centimeter wheel. So when I give these measurements like 5.6 and 8.8, these are the diameter of these wheels. You need to know this because that kind of determines how far your robot will go in one rotation. So over here, as I said, this is the diameter of the small wheel. And circumference is pi times d. So over here you will see that any kind of wheel, this is the diameter, the longest line that passes through the center of the wheel. And then circumference is like a imaginary thread that goes all around a imaginary line. Line is straight, but like you get the idea, that goes all around this wheel one rotation, and that is equal to pi times d. So if your wheel is 5.6 centimeters, you should enter 17.5 centimeters in that block, because that's the circumference, the distance this robot will go in one rotation. If your wheel is this one, which is 8.8, we should enter 27.63 centimeter. Again, the circumference is equal to pi times diameter. The value of pi is 3.14 approximately. Okay, so again, if you open up a calculator and you put in 8.8 times 3.14, you're going to get 27.63, and that's our circumference, 27.63. Okay, so let's go back to our spike prime and put in here 27.63. That's the distance our robot is gonna go for this wheel. Next, we want to set how our robot is going to brake. So for this, we want to click on this add extension block at the bottom left hand side of the screen, and that shows you all the other blocks that you can then add to your palette. So we want to add more movement blocks, and then click X here, and that adds a whole another set of blocks under my blocks. Okay, and here we want to look for how the robot brakes. Now over here you can see it has three options: brake, hold position, and coast. If you put in coast, it allows the robot to stop after the inertia has died out, but hold position will allow it to like arrest its motion after its programmed rotation is done. And this is kind of important in FLL because we need it to like halt and do the mission. The brake will also do this job, but it kind of gives you a jerky stop, and that might throw some of your attachments and like the cargo that you have picked up with your robot around. So we don't want that either. We want to hold position, and then the last thing we want to do is we want to set speed, like how fast we want our robot to move. So we want to set movement speed to, let's say, 50%. And then we want our robot to move forward because that's why we're writing such a big code. So we're going to add this block which says move forward for a certain amount of centimeters. Okay, so let's say we want our robot to run ahead for 60 centimeters. Now remember, there are a couple of options here: centimeter, inches, rotations, degrees, and so forth. We're going to be using centimeters because it allows us to precisely map our field and get to places. Okay, so our code is ready, and next we are going to download this code and see it on the field. So you can see that our robot is set up at the start line, and then I have set a meter, a measurement tape set to 60 centimeters. And here's our code, and now we are going to download our code and see it run. And there it is. It goes exactly 60 centimeters. Now you can see that the robot, like, it's right in the middle of the wheel. So please remember, when we drive our robot, it stops right in the middle of the wheel. Okay, so now that our movement, like, motor block is ready, we need to make it into a my block so that we can call this all the time whenever we need it. So we are going to go to the my block palette over here, click on make a block. And this is very useful because then we can call subroutines and we don't have to remember to set like 4 things every time we use motors. So I'm going to call this motor move, and then we're going to take in an input which is the distance in centimeters. I hit save and then pull out this block which looks like this. We are going to move this part over here, and instead of 60 we're going to put in distance in centimeters. And now whenever we want to move any amount of distance, so let's say we want to move 40 centimeters, we put in 40 over here, and we can turn on our camera. Let me pull my robot back. So I need to set my robot back to its original position, but I thought I'll show you what we can do once our my block is set up. So instead we can put in -60 here and see our robot run. So I'm going to download and watch our robot come back to the start line. Isn't that beautiful? And so if you wanted to go 40 centimeters, we can put in 40 over here, download, and watch the robot run. So obviously this is gonna go lesser than 60, and this is how it looks. Now make sure that when you do programming in class, you use this motor move my block. Many a times I see students, they come to class and every single time they want to move their robot, they are fumbling around to find the right blocks. So for example, this is going to move only one of your motors. When you pull out just this block and you don't have anything initialized, this is not going to work for you. So for example, if I just put this and hit run, it's not going to do anything because we haven't initialized which are the movement motors, how do we, what speed do we want, how do we want it to behave after it breaks, and then what is the circumference of the wheels of that robot. So if you have not put any of those parameters, this block is not going to work for you. Okay, so that's why it's a better idea to write this my block and then go to my blocks, and every time you want to move, you want to put in this measurement over here. So if you want to go forward, you put in a positive value. If you want it to go backward, you put in a negative value in centimeters. Okay, happy programming.